Employee exposure to unguarded or inadequately guarded machines is prevalent in many workplaces. Consequently, each year over 800 workers who operate and maintain machinery are fatally injured, and then approximately 18,000 others suffer amputations, lacerations, crushing injuries, and abrasions, often resulting in permanent disability. There are many OSHA standards governing the guarding, safe use, and maintenance of machines and tools. During this training, we'll focus on OSHA Subpart O 1910.219, Mechanical Power Transmission Apparatus for General Industry. Mechanical power transmission apparatus is any device involved with transferring power from a motor to a machine, such as shafting, flywheels, pulleys, belts, and chain drives. Each such apparatus presents several hazards, the chief among them being nip points. In-running nip points or pinch points are a special danger arising from rotating or reciprocating parts. They occur whenever machine parts move towards each other or when one part moves past a stationary object. Examples of nip points such as a belt running on a moving pulley, a chain running onto a sprocket, or two gears that come together produce a point at which parts of the body, fingers, hair, or clothing may be caught between or drawn into the nip point, crushed, mangled, or severed. Another hazard of transmission apparatus is that it rotates, sometimes at great speeds. Various parts can break and be thrown, or anything falling onto these devices can be thrown at workers. A third serious hazard is burns and abrasions from body parts rubbing against rotating parts. Once caught and pulled into a machine, even smooth rotating parts can do serious injury to limbs in seconds. 219 Mechanical Power Transmission Apparatus Standard is organized by device types. 219A, General Requirements, informs us that this section covers all types and shapes of power transmission belts, with some exceptions for smaller, flat, round, and V belts running at 250 feet per minute or less. In this example, the table saw belt is running at 2,700 feet per minute and must have a full guard encasing belt and pulleys, not just the nip point guard showed. Per A2, this flat belt traveling at less than 1,000 feet per minute is exempt from the standard. However, must still be equipped with ingoing nip point guards at the pulleys. A good rule to remember is any machine part, function, or process which may cause injury must be safeguarded. A risk assessment should be conducted to determine how this machine is used and what hazards may exist. 219B includes requirements for guarding flywheels, cranks, and connecting rods where any part is within 7 feet of the walking working surface. Flywheel guarding may include the use of guardrails to maintain a safe distance. Where flywheels are above working areas, the guards must be designed and constructed able to hold the weight of the flywheel in the event of catastrophic failure. 219C addresses shafting. A common violation is to not fully encase shafting to prevent contact. Rotating motion can be dangerous. Even smooth, slowly rotating shafts can grip clothing and through mere skin contact force an arm or hand into a dangerous position. Injuries due to contact with rotating parts can be severe. Shaft ends must present a smooth edge and not extend more than half the diameter of the shaft unless guarded. Note that OSHA's machine guarding requirements provide no exemption from guarding based on shaft size or speed. 219D, pulleys within 7 feet of the floor or work platform must be guarded. Assess the risks to employees even for areas seldom accessed. The backside of guards must also be enclosed. Any openings must be small enough to prevent contact with hazardous moving parts. Those portions of belts that are 7 feet or less above the floor or platform must be enclosed. Gears, sprockets, and chains must be enclosed unless they are more than 7 feet above the floor or platform. The guarding requirement does not apply to hand-driven gears and sprockets. 219G, guarding friction drives. The driving point of all friction drives when exposed to contact shall be guarded. All arm or spoke friction drives and all web friction drives with holes in the web shall be entirely enclosed, and all projecting belts or friction drives where exposed to contact shall be guarded. Collars, couplings, cams, clutches, flywheels, shaft ends, spindles, meshing gears, and horizontal or vertical shafting are examples of common rotating mechanisms which may be hazardous. The danger increases when projections such as set screws, bolts, nicks, abrasions, and projecting keys or set screws are exposed on rotating parts. 219H requires these to be guarded. Collars and couplings are specifically called out in 219I in the standard and must be guarded. 219M provides guidance on standard guards and acceptable materials. Safeguards must prevent potential for contact, be secure, protect from falling objects, create no new hazards, be designed and installed to not interfere with the work, and where necessary accommodate safe lubrication of the machine. Conduct a risk assessment on each piece of powered equipment in the workplace to identify where corrections are needed, where to conduct regular inspections, and provide preventative maintenance. A simple risk assessment ensures that barrier guard openings are safe. meeting OSHA Table O-10 or ASME Table E1. A more thorough risk assessment would examine guard strength, condition, how the equipment is used and maintained, or other relevant information. A good guide for a risk assessment is ANSI B11.TR3 2000. Machine safety responsibilities are shared by all levels of an organization. Management must ensure all machinery is properly guarded. Supervisors must train employees on specific guard rules in their areas, ensure machine guards remain in place and are functional, and immediately correct machine guard deficiencies. Employees do not remove guards unless machine is locked and tagged. Report machine guard problems to supervisors immediately, and not operate equipment unless guards are in place. In addition to requiring appropriate machine guarding, OSHA also requires employers to train employees to recognize, avoid, and control hazards. Train those who work around power transmission apparatus to understand the hazards presented, the methods of safeguarding, and any applicable safe work practices. Refer to the user manual supplied with your equipment for proper use, maintenance, hazardous energy control, and inspection information, and ensure to include this info as appropriate for employee training. Guards shouldn't be installed and forgotten. Inspect regularly for damaged guards, missing guards, modified guards, and other problems. Investigate to understand why the unsafe condition was created and take steps to ensure it does not happen again. Develop and implement a prevention reoccurrence plan that includes training. For more resources and information on this subject, refer to www.osha.gov/machine-guarding or contact WisCon consultation with questions and to assist with your workplace hazard assessment.